Hello friends, good evening all of you. Today's session we are going to see about the graph theory from discrete mathematics. So discrete mathematics itself we have lots of concept. Really it's very important. So we know that already. So every units we are going to get 10 questions. But sometimes we can't say correct 10 questions. Sometimes we will get 11 to 12 questions. Sometimes 8 to 9 questions also. Okay. So this is a discrete mathematics. So before starting today's class, just I'll tell you some informations regarding paper 2. For example, unit 1 discrete mathematics. Yes, unit 2 already every unit we saw what are the syllabus are there. Actually, unit 2 it's a computer system architecture. Third unit is a programming language. So apart from discrete mathematics, you can see other units. For example, second unit computer system architecture is combination of three subjects. For example, the digital fundamental, computer organizations, and like this. Okay. And the programming language also, we have lots of programming language and computer graphics is joined together we are reading. So in this subject discrete only full and full mathematics. Really, if you do practice well, sure we will get out of 10 out of 10 also we can crack actually, but practice we need every questions to 4 to 5 times you can do practice. Really it will be very interesting actually. So graph theory apart compared to other concept, really it will be very easy and we can do fast also graph theory. Okay, now we can move on to the subject. Today we are going to see full and full what is graph and what are the types of graphs. That's all. Okay, we after that in graph theory itself we have handshaking lemma, this one, and the next one we are going to see Kruskal algorithm, Prim's algorithm, and what are the coloring graphs and bipartite today we are going to see. So like this we are going to move to different types of questions also with solution. Okay, now we can move on to today topic. Okay, first one graph theory. So graph theory what? A graph theory is a branch of mathematics that studies graph. So graph means a collection of vertices and nodes. So which are mathematical structure used to model relationship between objects. So just you can see vertices or nodes we can say. For example, in this diagram you can check it. This is called vertices or we can say node also, because sometime questions they will give how many number of nodes in the longest path. Maybe like this also they can ask. So we have to know what is vertices or nodes, the object. Edges or links, the connection between. This is called, for example, two vertices are there. This joint going to connect the two vertices. That is called edge or links, I can say. Okay. So example, they have given each city represent a vertex, and suppose this is city, for example, Madurai. This is for example, Chennai means this road represents called edges. Just we are going to move one place to other place. Actually, this is we can use in the traversal path. Everything everywhere we can use. So in this diagram, we can see G is a graph. So it's a collection of vertices and edges. This is the meaning. So vertices what? A, B, C, and D. This is called vertices. Edges means what? A, B, and AC, and BC. Next one, CD. So this is called edges. Okay. Okay, next one, degree or degree of vertex. So just I have put this degree. This is actually we have different types of graph that we are going to see in the next slides. Actually, this is called undirected graph. Directed means what? It will put direction like this. So this direction will be there. Okay, so depends on that the degree we can it will vary actually. So this is they didn't give anything. So this is undirected graph. So from A we can go C also, D B also. From B we can go A also, C also. Direction is not there, so no problem here. From C we can go A also, B also, D also. From D we can go only C. So that is the meaning actually this one. Okay. Now vertex you can see the how many vertex A, B, C, D given. So what is the A degree actually? Where is going out degree? That is called the degree of vertex V of a graph is number of edges incident with the vertex V. For example, from A where it is going A and B. So how many degree? This is 2 degree. And for example, C how many degree? This one 3 outside degrees. Outside is going 3 degree. Okay, B how much is a 2 path. So this is 2 degree. Y D means only one thing. So A for 2, B for 2, C for 3, D for 1. So which one is even degree, which one is odd degree? That also we have to know. Okay. Sometimes very rare they will ask the question, but this is easy questions. Easy questions actually it won't come. I will tell you while taking itself, it's a very important. Okay. This is even and odd. We have to know that. Okay. Next one, common terms. Degree means the number of edges incident onto a vertex. So path means what? For example, here I am going to move. Want to reach A to I want to reach D. So this is the path from A to C. I am going C to D. I am going. So I am reaching. I reached D like this. So this is called a sequence of vertices connected by edges. Cycle means what? For example, I will take the same diagram. Here you can see. I'm taking AC, CB again BA. This is there means this cycle graph, cycling. This is only means it will cycling. So a path starts and end at the same vertex. That is called cycle. What is connected graph? Every pair of vertex is connected a path. Tree means a connected graph with no cycle. So if it has cycle, actually last diagram, it has no cycle means that is called tree. Okay. So here this some example they have given. You can see vertices A, B, C, D. So vertices A, just I'll put B here and C here and D here. I hope like this they have given. Depends on the just I'm writing. I'm drawing here. For example, A, B, C, D. Now we adjust A, B, okay. Next A, C. So actually C this one, D this one. So depends on this I'm drawing diagram. So AC this one, next one BD, next one CD. This is they have given edges. Okay. So A of degree A degree. What is the degree of A? This is 2. It's going C also. It's going B also. For example, I'll tell you if it is a directed graph, I will put direct here. This is I'll put direct here. I'll give direction here. I'll give direction here means automatically A degree will be 1. If it is directed, depends on the arrow it will put out. Not now actually that I told you. So if it is given that concept. On one path from A to D, sorry I have left out. This is A, this is B, this is C, this is D. Yes, I told you like this only. This is the graph actually. A to D. I want to go A to D means I can go A, B, B, D also. And one more thing, A, C, C, D also I can go. This is up to this where we are going. And this graph contains cycle means A, B, B, D, C, D, C and C, A. That is called graph cycle. So graph cycle means what? Start and end at the same vertex. That's our graph cycle. Okay. So like this diagram, whatever diagram, we have to understand how it is working this one. Okay. Next one, we have types of graph. So null graph, actually we can put one vertex also. This is called graph only. Okay, here null graph. First one null graph. A null graph also called an empty graph. It's a graph contains vertices but no edges. It has only one thing. For example, 3 vertices are there but not connected means also that is a graph. This null graph. So none of the vertices are connected to each other. Okay, this is empty actually. Edges is equal to empty. Okay, what is a simple graph? What is a simple graph? A graph is called simple graph or straight graph. Is a graph is undirected. Undirected. We have to know what is directed, what is undirected. It's very important. So whether its arrow is there means this is a directed graph. Arrow is not there means that is called undirected graph and does not contain any loops or multiple edges. For example, I have like this and I have like this going means this is called multiple edges, multiple parallel edges. For example, I have self loop means this is called loops. So here it won't allow any simple graph. It does not contain any loops or multiple edges. That is called simple graph. Okay. A simple graph is an undirected graph that contains no self loop, no multiple edges. Actually, sometimes the statement questions, they will give you simply which one is undirected, which one is contains no self loop and no multiple edges with some pair of vertices. Which one? There's four option: simple graph or multiple graph or null graph or choices they will give. So we have to know this type of question also. Okay, but we are going to get two exams nearly. It's a set exam as well as net exam. Sometimes set exam, maybe theory questions also may can come. Maybe we'll get. Actually, before net exams, actually we used to get 60 is to 40 ranges. For example, 60 application oriented, sums oriented questions. We have in computer science fields. Actually, we have lots of calculative based, calculation based one. So 40 theory based actually we used to get, but nowadays we are getting many questions, chronological order questions, match the following questions, statement based questions. 40 is to 60 also we are getting. Theory 60 we are getting. So we have to focus more in this one, this type of theory based question. This is theory based question. Like the statement based questions, whenever we will get match the following questions also we have to focus. Actually, in discrete mathematics, we will get lots of match the following questions. So that we are going to see separate session that will be very good because match the following nowadays we are getting so many questions. Okay, that we will see conduct a separate session. Okay, a graph G is V comma E is called a simple graph if there is no most one edge between two distant vertices, no edge connected vertex itself. That is called self loop, no nothing. Okay, this is depends on that we have drawn the diagram. This is also we can draw. Actually, this is other diagram. This diagram actually already we have drawn A. This is B. This is C. This is D. This is C. This is D. Like this we have given. So this is called AB, AC, BD, CD. Like this we have drawn this one. Okay, this is also simple graph. Next one, multigraph. Multigraph or parallel graph we can say. This is like this multigraph or parallel graph. Parallelly it's going to join to this one. A multigraph is a graph in which two or more edges are called parallel or multiple edges are called between the same pair of vertices. However, self loop are not allowed. For example, I am putting this one self loop means it won't allow here it's saying that's all. Okay, so we have to know which one is which type of graph. So graph G equal to V comma is called a multigraph with the multiple parallel edges may exist between same pair of distant vertices. Okay, self loop are not permitted. Next one, self loop graph, you know, just looping it's come. Directed and undirected graph. This is very important. Actually was simple graph only, but it's going a simple graph, it's an undirected graph. Okay, but here directed means like this arrow will be there. You can put degree here, degree of vertex you can put here. For example, in this diagram, A what 2 degree, B what 2 degree, C what 2 degree. Now we can put here actually A what 1 degree, B what 1, C what 1 degree. That's all. Like this we have to make it as a degree of vertex also for every diagrams we have to know. Okay, graph G equal to V comma E is called directed graph if the edge set is made up of its ordered vertex pair, and graph is called undirected if the edge set made up of unordered vertex pair. Okay, just I told you the through diagram itself, it's more than enough this one. Okay, next connected a disconnected graph. This is connected, this is disconnected. While seeing itself, we can understand actually it's not connected actually properly. Okay, a graph connected, two vertices graph are connected by a path. The graph is disconnected if at least two vertices graph are not connected by a path. That's all. Regular graph. Regular graph means the same degree. The graph is regular if all the vertices of graph have the same degree. That is called regular graph. For example, you can put for this diagram itself A and B and C. The same diagram I am writing A, B, C, D. Okay. So this you can put this one A, B, B, C, B, C here, B, C, C, D, D. Okay, B, C. Like this we have to put, depends on the edges they have given, I am writing. Okay. Now this is C, this is D. Now you can put A, B, B, C, C, D, D, A. Anything, depends on the edges or edges we can change. Now what is a degree? Degree A, 2. B degree 2, C degree 2, D degree 2. So everything is a degree. Degree of A is a 2, degree of B 2, like this. Since every vertex has degree 2, this is a 2 regular graph. Okay, complete graph. So the graph is called complete graph if every two vertices of every path joint exactly one edge. That is called complete graph. Denoted by Kn. Cycle graph means the arrow you can see. A starting B, B starting C, C joining the same vertex which you have started here. The same thing. If a graph consists of single graph, called cycle graph. The cycle graph with an n vertices denoted by Cn. And bipartite graph. So first I'll tell you these things. In graph, we have four types of graphs. It's very much important. They won't ask you in net exam, in competitive exams, set exams, actually, what is the null graph, simple graph, multiple. They won't ask you like this. Actually, they will focus actually what is bipartite graph, what is planar graph, what is Euler theorem, Euler graph, what is a Hamiltonian path or circuit, like this. This is very important concept. Again, I'll tell you. In graph, we need to focus four types only. Maximum, they will cover this type of graph: bipartite graph, planar graph, Euler graph, and Hamiltonian graph. Apart from that, coloring graph will be the important thing. Okay, what is bipartite graph? Bipartite means it's a graph whose set of vertices can be divided into two distinct sets. Means this is A, B, A, this vertex, one vertex site, this is a vertex 2. So it won't join same vertex. So such that every edge connects vertex from one set to vertex from other set. No two vertices within the same set are adjacent. It won't be there. It won't join this one. It won't join this one. It won't allow. This is not a bipartite graph. Okay, that's we have to need to clear that. So this one vertex set means this one vertex set means it will join one vertex to other vertex. That is important thing. So what are the characteristics? The vertex set is divided into two disjoint set. No edge exists between vertices of the same set. So every edge connects a vertex from one set to the other. So the graph is bipartite means if and only if contains no odd length cycle. In complete bipartite graph, k of m, k substitute this one m comma n, k base m comma n. Now we can see this is complete bipartite graph. Actually, it is connected full and full this one. This is complete bipartite graph. A complete bipartite graph is a bipartite graph in which each vertex in the first set is joined every single vertex in the second set. So this one it's connected C also, it's connected D also. B it's connected C also, B it's connected D also. That's the meaning it's saying. The complete bipartite graph is denoted K base x comma y. So normal what km like this will be there. So this is two sets actually x comma y, where the graph G contains x vertices in the first set and y vertices in the second set. So a bipartite graph, based on that we are going to work out next one. It's very important thing actually. So which one is important? Kindly make notes of it. Actually maybe they can ask in the theory question also, direct statement questions, direct definitions. So that we have to know this concept. Next one more important thing is a planar graph. What is a planar? A planar graph is a graph that can be drawn on your plan without any edge crossing each other. For example, you can see suppose it's crossing A to D means that is not a planar. The edges it won't allow to cross the edges. This crossing edges it won't allow. That's the meaning it's saying. Okay, if it is one, if you want to draw A to D, it has to draw like this actually. It will be allowed, but it won't allow to cross the edge actually. Already one edge is here. It won't allow to cross this edge. That is the meaning it's saying. So this is called planar. So the graph G equal to V comma E is a planar graph if it can be embedded with a plan such that no two edge intersect at their endpoints. Okay. Okay, non-planar. What is non-planar? Non-planar means it will allow to cross the edge. It's a graph that cannot be drawn on a plan without at least one pair of edges crossing, regardless of how the graph. So this is non-planar graph. Okay, example non-planar K5 we can say at K parted 3 comma 3 we can say. Okay, actually they will tell you to find out some images. They will give 4 to 5 images. They will tell you to find out which one is planar. We have to make drawing. It's a different shapes and we have to make it whether clear is it planar or not. That we are going to see the questions also. Okay, maybe tomorrow we are going to see that questions. Just today types of graph only. Euler graph. Euler graph or Eulerian graph is a connected graph that contains Euler circuit, that is a closed trail with that starts and ends at the same vertex. It's very important. It travels every edge exactly once. This is very important because Hamiltonian every vertex exactly once. This is concept difference that only they will ask you. So every edge exactly once, whether it's a Euler graph or Hamiltonian or planar or something, they will ask you. Okay, here you can see every vertex. This diagram, you know, A, B, B, C, C, D. This is A, B, A, B, B, C, and C, D, and D, A. This is the diagram actually. So every vertex even degree we will get 2, 2, 2 like this. So since the graph is connected, every vertex has an even degree in the Euler graph. Okay, Euler circuit means it has to connect start and ends at the same vertex. You can see A to B, A B to C, C to D, and D to A. So just arrow we can put. So this is called Euler graph. The circuit starts and ends with A and visit exactly edges exactly once, every edge exactly one. That is called Euler. Characteristics, the graph must be connected and every vertex has a even degree. This is important, we have to remember, contains at least one Euler circuit and every edge travels exactly once. This is the meaning actually they have given the same diagram also. Okay. Next one, Hamiltonian graph. Hamiltonian graph is a graph that contains a Hamiltonian cycle. That is a cycle that visits every vertex exactly once. Kindly note down. They won't ask you more. They won't ask you so much in the regarding the diagram actually. In types of graph questions, Hamiltonian and Euler and planar, they will give diagram and they will ask you. And bipartite also they will give calculation based one. But Euler and Hamiltonian they will give maximum that statement based question. So kindly note that every vertex means it's a Hamiltonian based one. Every adjustment this is called um, this is Euler based one. So we have to remember keywords important thing. So that's why I have just done bold. So and returns to the same vertex. So this is the diagram. A, B, C, D, E. They have given A, B, B, C, C, D, D, E, E, A. Okay, the cycle it's called this one. So the visits every vertex exactly once and return to the starting vertex. Hence the graph is a Hamiltonian graph. You can see this one. It contains a Hamiltonian cycle. Every vertex is visited exactly once in the cycle. The cycle starts and ends at the same vertex. Okay, and a Hamiltonian cycle does not repeat vertex. Here again, note down. Here it won't repeat vertex edges. It can repeat, but in what Euler circuit, it edges it won't repeat. Vertex can repeat. It just won't repeat. Which one is won't repeat? That one only kindly note down, except the starting and ending vertex. Unlike Euler graph, Hamiltonian graph focus on visiting vertices, not edges. Vertices only it will point out. Okay. So this like this we have to take this one. These are the types of graphs actually. We are going to cover up to this one today. So tomorrow we are going to see about handshaking lemma based questions and very important thing next video. Kruskal and Prim's algorithm questions I am going to cover. Really, it's very interesting and very important also. Kruskal and this one Prim's algorithm. Really sure 100% you will get this type of questions also. So kindly subscribe my channel and you can visit this one. And I told you already, if you have any doubts, you can ask me in the comment section also, or you can join in the WhatsApp group which you have given in the channel. Sure, you will get lots of notes and doubts will be clearing through WhatsApp also. And thank you all of you. Thank you once again. Uh, okay.